Hello and welcome to Energy Hour, everyone. Thank you for joining us. My name is Fernanda Schmidt, and I'll be your host today along this great group of speakers. I'll introduce them shortly. The title of today's discussion is Preventing the Blackout, and unfortunately, that's not a metaphor anymore. Energy systems today are more digital, they are more interconnected, more regulated, and in many ways more fragile than ever before. I'm sure you all remember the blackout in Portugal and Spain last year. It was the most severe blackout in Europe in 20 years. But not only that, markets are accelerating. There's additional pressure coming from and complexity coming from renewables and new energy sources. You have cross-border dependencies increasing, and you have risks increasing as well. On top of that, we also have reporting, regulatory demands, putting pressure on organizations. You have on premises, you have hybrid systems that must be connected, data that needs to flow, and operations that cannot glitch, which means that the digital layer connecting everything is now critical infrastructure. It also means that we have a lot to discuss today. If you have joined our group in the past, you know that we have a space for a Q&A, and I will make sure to get to it by later on. So send in your questions and we will go through them. I would also love to hear your thoughts on today's topic. How can we prevent the blackout? So let me introduce you to our speakers. I'm joined by three experts who each bring a different lens to the discussion. We have Andris Spielbags. Andris is a former EU Commissioner for Energy and professor at the European University Institute's Florence School of Regulation. Welcome, Andris.
Nice to be here.
We also have Rob van Kranenburg. Rob is the founder of the IoT Council and vice chair at IEEE's 6G Working Group. Welcome, Rob.
Thank you. Thank you for having me. Yes. Yeah.
And we have Simon Lopez. Simon is a project manager at Volue, a leading Nordic technology provider enabling Europe's green energy transition. Welcome, Simon.
Hello, thank you.
So we are here to talk about resilience, operational resilience, coordination, governance, and what it actually takes to keep the lights on in a hyper-connected world. So I would like to begin talking about pressure. Simon, from your perspective, what is putting the most pressure on energy system reliability right now? And what does it look like, or what does pressure look like when it reaches operations?
Yeah, there are mainly two things that I see in kind of a day-to-day operation in the context of integrations, and that is one of those are time limits, like the old 1 hour MTU, market time unit, that went to 15, and that puts on a pressure on decision time for humans. If there's something that is perceived as critical, you have less time to react to it. The second issue is third-party dependency. We rely for our optimal process on third parties' data, and if in some cases, if one of those third-party data don't exist or are unreliable, it will, for example, cause disturbances in our market calculations, for example, for balancing markets. So those two things are the two pressures that lands directly in our team.
Mm-hmm. And when we talk about integrations or the digital layer and what's behind energy operations, we don't really understand how much of a threat are they facing. So I saw a report from the International Energy Agency, and it said that electricity and gas utilities in Europe faced over 1,500 attacks per week in 2024. And that was 3 times more attacks than in 2020, for example. Rob, are blackouts becoming more likely because of technology limits, or is it something else?
I think, well, in kind of a more general way, the blackout is already here, in the sense that, for example, in Holland, there's 15,000 companies waiting to be to get power in order to work, basically, because the grid is not able to handle. And around Eindhoven, around ASML, which is our most valued company in Europe, there's 900 companies waiting, and so there's also a lot of positive things coming out of this. Is that that in Eindhoven at the moment, people are looking at how can we create energy gains? How can we create more efficiency in these systems? Because they have very interesting and important, vital startups with great ideas that can simply not get power. So that's that's happening. And on the other hand, I think we've seen growing awareness of this in political levels. For example, the 24 PCAST report to the president talked about a strategy for cyber-physical systems and cyber-physical resilience, fortifying our critical infrastructure, as it was called. And this is a call to look at the entire infrastructure, connectivity, water, energy, more holistically, and look at it as one cyber-physical system. And this is going more in the direction of how China is now able to steer policy on batteries, battery energy, battery storage, and is able to actually have 10-year, 15-year plans, which is something that this report asks for. And it's been taken up a little bit by the European Union in its Resilience of Critical Entities Directive, which was also 24, 25. And this is a directive for all critical operators to look at, to broader look at resilience. So it's more than energy alone.
Mm-hmm. And it's interesting that you mentioned China. Andres, do you see Europe struggling more than other regions to anticipate these issues or deal with them?
No, I would in short answer, I think Europe is in forefront. We have very good experts, we have equipment, and we also are driving our electricity system for change much faster than anywhere else. But it's also true that the biggest pressure on reliability is the speed of transformation. So we are decarbonizing our electricity mix, we are integrating intermittent resources, we are electrifying transport, heating industry, and on top of it's digitalizing operations. There are cyber attacks that you mentioned, and additionally, we have a very centralized, we used to have centralized generation, and many of the grids are 40 to 50 years old. So what changes now is that also Simon touched upon it, that we need to manage highly complex systems. And Fernanda, you mentioned the Iberian Peninsula blackout. I think that gives the good perception what actually happens. When you read official reports coming out after investigation, it's very difficult to say what actually has caused this blackout. I remember when I was energy commissioner, there was one cable cut, and then we get a brownout. So it was very simple. Here, there are a complex chain of technical failures in electricity grid. So there is surge of voltage. This overload is making the generation units to disconnect from the grid. There is a cascade and system collapses. And if you go to and ask why the grid voltage was so unstable, then you say, well, again, there are many factors, but the main factor actually seems is to be that in Spain, grid operator at that day had not so-called enough synchronous generators running. So it was a lot of renewables, and there have been not enough of these synchronous generators, and system could not cope. But in essence, what we have learned that the problem is not actually with technology. People know how technology, but you need to anticipate, and you need really manage the highly complex systems. So these systems will more and more complex, but at the same time, it's not because of technology limitation. There is really coordination and governance challenge. So Iberian Peninsula, we can learn from it. With technology, we have new challenges, but you need to anticipate, you need to coordinate, and you really need to govern. But Europe definitely is at forefront, and I could say that we are reasonably well prepared that these blackouts do not come again, but we can't exclude because system is still in development.
Yeah, yeah. And anticipating means being proactive, right? And whenever we
Exactly.
talk about, and whenever we talk about digital transformation and getting ahead of the challenges, we usually see the cost of doing nothing as a concept that comes up. And Simon, from your perspective, what is the risk of doing nothing right now? Like, what do companies have to lose?
Well, in the context of integrations again, right? And from my perspective, that are kind of representing the flow worker on this data going back and forth. Doing nothing is a bet on certain failure. You ask me, it's a really risky thing to do. Older integration platforms might struggle with keeping pace with this increasingly real-time data flow that needs to be there, right? With the shortening of the time resolutions, which even it is talked that resolution should go down to 1 minute, right? So it's to keep an even tighter ship going, but yeah, so it's very risky if you ask me. We need in the worst case is that in our company is that you lose revenue for customers. That's kind of the worst thing that can happen to us. It can have financial penalties by not being compliant with the market regulation, right? And we talk about governance requirements that has been put on different companies from financial institution, national or otherwise. The great issue is that these small gaps accumulate and can accumulate quietly if you do not have a kind of a visible integration platform that helps you do so, or enables you to create your own tools too, right? Yeah, so the compounding over time is an issue on the small gaps, on the small errors. That's the risk of not integrating as best as you can, I think, and it's increasing your risk really fast.
And do you agree, Rob? How do you see it?
Yes, I agree both with Simon and Andres. And 2005 was the first time that the European Union actually got to 30% of wind and solar, and outpaced fossil. So I mean that's a huge success, and this has been through tremendous coordination. But I mean, at the same time, we see that the energy market has been caught up in some kind of 19th century, sort of 18th century type of war-like thinking. We've seen, and we see recently that very vital installations are being destroyed and blown up. And causing huge stress on energy and energy prices. And we see that the Commission is very strong and fast reacting in terms of energy sovereignty, in terms of cutting off certain suppliers, creating also internal problems. Like, for example, like I just said, 14,000 companies in Holland just waiting to be started to put in a plug. I mean, this is very strange. So I agree that in certain ways of thinking, the Commission can act fast and proactively, but in overall terms, in terms of digital sovereignty, strategic autonomy, of course, we've lost immense notions of proactive power in the last 25 years because we missed all the waves, and we're about to miss another wave. And this is, I think, because the political mindset in Europe has been very much legal and economists, and in contrast to the Chinese leadership, which are scientists and engineers, they immediately understood a hybrid reality. In Europe, I think most of our leaders do not understand that, and they still think in terms of analog plus a little bit of digital, analog plus a lot of digital. But the thinking is there's no coherent leadership thinking on strategic autonomy in this term of these cyber physical systems, hybrid systems, where you look at what regions and territories are needing in terms of infrastructure, connectivity, water, energy, and you take that together. And then the trend is towards distributed. The trend is not towards building bigger data centers, to which we see also grassroots protests now in the States. People are protesting against these huge data centers because nobody sees real profit at the moment beyond some large language models making people write better blurbs or something. But it's not really down into physical AI. So we don't see AI robotics operating in energy systems going towards self-healing energy systems or self-healing water systems in which 50% of our drinking water is leaking at the moment globally. Globally today, every hour, 50% of clean drinking water is going down the drain, basically. So that's where we need to have efforts of AI, physical AI, not in these huge data centers. And so I think the future is much more distributed. It will go into much more device infrastructure. The device infrastructure will be much more capable of being able to be serviced by community battery infrastructures or home batteries. That's where things are, I think, at least in China, are going. It's a tremendous amount of millions and millions of these units. And so I think, so we have to try to look more distributed of this towards this future.
Yeah, and you talked about hybrid systems, connectivity, and we've been talking about pressure as well. And integration is your bread and butter, right, Simon? And we're talking about the layer that connects everything. And if energy systems are becoming digital and cyber physical, then the integration is not just IT, it's also resilience. It's, as I mentioned in the opening, like critical infrastructure. And what makes integration architecture safe or unsafe in energy operations, Simon?
Yeah, when I was thinking about this, I see kind of more or less four things: visibility, control, creating space for human judgment, and address it proactively or react at it when all is burning, right? And to be concrete on when we do, for example, balancing calculations for our systems that going to use that for in many contexts, you're 30 minutes to gate closure to do a bid on the power market, and you're lacking clean data. In my context, the Nord Pool doesn't have some trading information, right? The weather forecast is sending corrupt data for some reason, right? Not seeing that in our integration context, right? Not having control over it, and not being able to create a space for a human to look at this and they say that, oh well, the weather in the region that we're talking about, for example, is stable, it's the same as yesterday, I'm going to put in those numbers manually, right? But you have to have time for it, right? And if this happens 2 minutes before gate closure, you can't do it, right? And you have to retrospectively kind of just tell the customer, hey, you lost 10,000 euro yesterday because the weather forecast was bad. So it's more about it's redundancy. That's one thing, right? Why do you have only one weather forecaster, right? And thinking on these issues proactively. Detect the issues as they unfold. It's kind of a little tagline I have for myself, and that's I think that's accurate.
Mm-hmm. And Rob, from a more holistic point of view, what makes systems trustworthy, would you say?
I think so the trustworthiness is in the stability of the connection and the stability of the transmission that you receive and that you get. So I think the way electricity was conceived and thought of, and the way that we have it, is not ready. I mean, like our societies were not ready, basically, for the internet and at the moment for AI. So the strain that's going to be put on systems because of these tremendous AI needs, they need strong governance. So at the moment, I think if we look at the situation in Europe today, in Holland, for example, in August 25, 4% of Dutch people had trust in their government. 4%. I mean, and the pollers, they just looked 3 times at this data because they couldn't understand it. Now I think it's sort of up to 19. But in a strange way, the trust in the Commission is at an all-time high. So as of early 2026, the trust in the Commission is in a 17-year all-time high, which is 51% to 52%. That's amazing. So to me, it sort of shows that people have enough of these notions of representative democracy, this voting every 4 years, to a party that basically they have very little knowledge. I mean, these politicians are, I mean, they're sort of voted on because of they have some charm, they have some ego, they talk nicely and sort of all of these things, and they get voted. And sort of our countries at the moment, our parliamentary democracies, are able to sort of steer 2 or 3 years on things. And this is no longer really acceptable to me as a citizen. To me as a citizen, it's decreasing my own capabilities as a citizen. It's decreasing the value that I can create. It's a 19th century system. It's in Holland, it's 180 years old. And it simply no longer can cater to what we need in terms of governance. So what we need in terms of governance is 10, 15 years of planning. Again, like it's possible in China. I'm not going to advocate for a Chinese system as a whole, but at least China and the Chinese and politicians, being engineers and scientists, had the only proper response to the digital. And now we see how they can steer on all these layers. And Europe is in 85% of dependence on hyperscalers, trying to build some sovereignty with very little to show for, actually. So I think this high confidence in the Commission is something that we should seize immediately. And build strong 10, 15-year governance on the AI, IoT, 6G layer that's coming in 2030. So this triangle of AI, IoT, 6G, that's where a lot of things are going to happen and a lot of new value is. And that's where we should look at. And then we should look at the native applications coming from this triangle. And we should look at that through the lens of energy, through the lens of water, through the lens of connectivity, and governance. And I think that's what we aim to do with the IEEE group. Yes. Yeah.
We started talking a bit about AI now, and Simon mentioned like human in the loop. And from a failure from a governance and compliance perspective means someone must be held accountable, right, Andres? So how does automation affect responsibility?
Yeah, I think if we go to the example of the Iberian blackout, actually we could not identify clear responsibility. And it means that something is wrong with the system, because when it happened, I discussed with some experts, and most of us said it's cyber attack, because it seemed like a third party. And when you read final report, you again don't get whose responsibility. I understand that automation makes system more complex. And that means what Rob meant. Governance is even more important, because if you have no governance and system is getting very complex, then it will fail. And you will never decide, well, and it perhaps does not matter anymore who was responsible, who failed. So the system should be built that if system fails, we know who and who is accountable and why exactly. Is it network operator? Is it regulators failure? Or it is a European Commission failure that did not bring some new regulatory requirements that are needed to deal with this? Because if we give for safe architecture of system, what we need, clear accountability lines. We need separation between IT and OT. We need redundancy, what Simon mentioned, and fail safe mechanism. We have also need full traceability of automated decisions, because time is getting very short. A lot of decisions are taken by automatically, but you need to trace it. Where the system failed, and then over it, you need independent oversight. But here I would defend a bit European system. European system definitely seems chaotic, slow, and whatever. And I agree with anticipation part. But Chinese system with engineering has also immense failures. Remember one child policy. It was human sufferings, and then they can't get out. So engineering state has also a lot of weaknesses. And Europe's system with many actors having some rules and some regulation common, and also some specific, is rather resilient. It's better resilient than we think. The risk in Europe, where I fully agree with Rob, we don't anticipate. We really act, things go wrong, we improve. Things are going fine, we are fine again. So we need to see a bit more ahead of us. And that is correct both for political processes, but also for technology coming in. And it's definitely a completely different time when I was as a commissioner. Even then, electricity systems have been very particular challenge, but now it is even more from political point of view. But you should be wise and leave to experts to decide what is needed, but keep these principles that I mentioned for safe architecture, that you could take, yes, system response, we have new technology in, how does it change the architectures that we have in place?
Yeah, and I think 2026 is the year where AI is in every discussion, boardroom discussion, strategy plan. So everyone is running to make the most out of it and get it into production as fast as possible. And I'm really interested in your take, Simon, because I know your team members are eager to explore AI features. We've talked about transparency and traceability as well as things that are super important for people to be able to trust and get the results that they want from AI. At Friends, we launched the AI Intelligent Connector. We can add AI tasks straight into workflows. We have MCP apps coming up. So like everyone is developing everything they can at the fastest time possible. So where do you see, but some of the things are still in development. We do have features now, but it's an ongoing process. And where do you see AI adding value to operations today, Simon?
Yesterday we were in a meeting with our company CTO where we were like 400 engineers in a meeting, getting the news that yes, indeed, we are going for this enterprise licensing for AI, and in the context of Friends, I'm 100% sure that it will have a place in our strategy in doing integrations. I'm confident on that. But as for now, it makes for me at the moment it's yet another tool that we use to get to do work easier, right, or more secure, faster. Also, in practical senses, I think that the AI tool in Friends will help us, for example, summarize logging, for example, right? You point at the logs that tell we had some disturbance. Can you see through the logs and tell me what happened? That kind of stuff, right? It's a tool to do the debugging, if you want to call it that. The interesting part is that the AI can do this while in the task and prevent that you have that disturbance. But we have this is the kind of who has the responsibility and the governance, the requirement that we have too, right? In our department, we have been using AI for a while now, but everything that we write, that we suggest, right? We say we take kind of a note, the authors, the AI XYZ, right? Verified by Simon, project manager / because you have to take ownership about it. It's not good enough to say, oh no, it was the AI that did it. Oh, you didn't check, right? In an engineering sense, this is the testing that we do. We don't ship products to production without testing. And then humans has to be responsible to do the testing, right? And verify that they're actually doing what you're supposed to do, and that the test battery is complete and 100% compliant with again the requirements that you do have, right? So I think that aspect has to be thought of before we kind of go all in AI and let it let it loose on our processes. I don't think that's going to happen. I think there's going to be a human oversight over this, especially because the risk for failure can have great consequences. And the MCP approach that is in the roadmap for Friends, for example, I think that's the efficiency tool that we are looking for, right? That a small group of integration specialists can handle all the integration of our company, for example, or our department, depending on how much it is, right? Then you can tell the AI, right, I need to do this integration, look at this documentation, where's the been done similar stuff before, can you give me a suggestion on how to do this in France? Set it up in France in a test environment. You press the button, you wait a couple of minutes, and then it has a suggestion, right? Then you open France and there's the process, and you can test it with your human eyes and you test batteries and whatnot. So I think that's the aggregation of value for the AI lays in that kind of stuff. But again, human judgment has to be part of it. I think, right? Unless some philosopher comes and tells me and give me a really good lecture on why not. But I haven't heard that argument yet. So.
And I think when it comes to like implementing new technology or how markets are regulated, legislation then plays a big role, and not just AI. But we're talking about energy sector today. So we had the recent 5-minute settlement in the EU. Norway has implemented something similar. The UK has its own accelerated settlement, T+1. So yeah, and whether it's an EU directive or a more market-specific legislation, I think the goal is always the same, right? Is getting more real-time data, faster reporting, stronger grid stability, and I think AI comes as a layer to that. Andres, how do you see these new energy directives and the role that legislation plays in deploying AI securely, not only in the energy sector in this case, of course?
Well, I think I need to start, Fernanda, what you just said, that 15-minute settlement actually was necessity. You have more renewables, you need to be more precise and anticipating when it comes in, because otherwise it's very difficult really to manage the system. So it's not that regulation invented it, it is just a requirement where EU is going. For AI, it's complicated. Normally, when we talk about AI using energy, we talk that we will need more power for data centers. As a use, there is always some caveats. One is that AI hallucinates. There is hallucinations sometimes. And if it would happen in the electricity system, just let's say some forecast completely wrong, the whole system could collapse. So the challenge will be how regulation could design a system where AI could be trustworthy. So it is really not so much problem, I assume, with AI, but with regulation. AI will continue to develop. It will give more chances, like high quality data, automated validation, so forecasting. But at the same time, you need to be sure that what AI does, it improves the system, strengthens the system, and you can trust it, because you need all the time balance between demand and supply. So we are at the beginning of the process, I would say. We can't avoid AI in electricity system, but under which conditions it could operate and will be used, it's a challenging task.
Mm-hmm. Do you agree, Rob? What do you see the potential risks of AI use in energy operations? How can you mitigate it?
Well, I agree both with Simon and Andres that that we're at a very sort of some kind of critical moment, where some people don't mind sort of like turning over sort of large data sets to an AI that basically at the moment we don't really know what's trained on. So it's really something that we cannot do. We need to have this human in the loop. But I think sort of the key of what I've seen the past 20 years sort of is that to understand this digital transition, you have to understand that the gaze of the network is relatively semi-autonomous. So for the network itself, for the AI cloud sort of hybrid, sort of intermingled network, everything's an entity. So at some point, you sort of it just looks at the world sort of as entities, and it's not human in the sense that how we look at that, and we're making that mistake. So from this AI gaze point of view, everything's totally flat, and because of a color blue, you might have more in common with your neighbor than your car, or with the car with the neighbor, and equality alive and dead is interesting to us, but not to AI, because it's just another quality. So if everything's entities, and there's no way for us to stop this wave of AI, we have to take up that position of and ourselves in this level of governance, and realize that we're going to have to govern these entities, and these entities are combinations that do not act and react to our 19th century, 20th century notion of how energy systems were built and worked with very stable flows of going through devices and things. So again, I think that the trend is towards distributed, is that we will see designs in which an operating system, an AI, will run from a chip, and that's where you embed your trustworthy AI. So you will build a device ecology. I mean, that's, I think, what's going to happen, and with me, lots of other people. Again, in this kind of 6G environment, and if you look at 6G in the SNSJU system that Europe has asked to govern, that put some governance on the 6G field, is about 80 to 100 projects already. I urge and encourage everyone to go and look to the SNSJU projects and look at the 3-year waves. And one of the key ideas in 6G is energy efficiency. That's the key, sort of the one of the main reasons for having 6G, according to the telcos at this moment and engineers working on it, is that it is much more sustainable and it's more energy efficient. And this is also because it's looking more holistically at this device infrastructure. For example, you get SIM-less devices in which the authentication and identity is much more a software issue somewhere else. So I think we really have to redefine our energy infrastructure based in terms of how a device ecology could look like in 2030. And this is also including the battery storage, thinking more in terms of these community batteries, where you have every street has one, for example, and thinking in terms of well, I read 20 years ago this very crazy proposal that if I was going to plug in my car and charge it somewhere with my friend, I should get the bill, so that the grid would basically have this identity known somehow baked in. I think these are the things that we can build, and that's where Europe, again, with this tremendous 52% of percentage of acceptance and I wouldn't say enthusiasm at the moment for the Commission, but still backing, and these extremely low figures of national countries in France and basically Germany and Holland, where people realize that these national sort of governance systems, a minister of energy in the Netherlands is just makes no sense. It makes no more sense because there's basically no agency at all at that level anymore. So Europe must take this governance view now, and I don't see the vision at the moment. I think the people and the Commission at the moment is not giving me as a citizen a good story of the digital and how Europe is planning to build its cyber physical system. Because if it's not building its cyber system, again, we have 85% of dependency on US hyperscalers, and with the wallets that are coming and that are going to be embedded in either Google or Apple OS and phones, we'll go to basically 90 and 95% of dependency if we don't have some vision out there soon. So I think it's really a holistic story, and we have to look at it in this cyber physical way in which the Americans are also doing it.
You talked about quite futuristic things now, and looking into this future. One question for all of you: what should organizations do now so that they are prepared for this future that is coming? And we are running out of time, so just one question for you all, and then I'll go to the our audience.
I can start. As a project manager in a private company that does operate in the power market, I think integration complexity is mitigated with the coordination of systems. I think that's kind of the in my role as project manager. I think that's a good answer to that.
Andres.
Yeah, from my side, I still would go to the blackout, because if the blackout like Iberian happens again, we have two problems. We lose economic value, but we lose also people trust. So for me, everything should be done to avoid big systemic cascade failure. So I think that's the biggest risk that we are facing now. Measures need to be taken, anticipation should be done, and really we should be efficient but also safe.
Rob.
Well, I would do what the brilliant Steve Jobs did when he came back to Apple. He went to the Foresight division and he said, you can do two things. You can either go because I'm going to fire you, or you can go and work with the product teams. And then he said, research will be done in the crucible of development. And he did. So all the people who wanted to stay from the Foresight division were working with the developer teams, and the people who didn't want to do that, they left. And he didn't have a Foresight team anymore. It was embedded in the company, and that created the iPhone. So at the moment, for the individual companies, it's such a mess. There's no way you can look further than 5 minutes or 3. So stop looking forward. Just go inside. Bring all the forward knowledge into the product teams, and for the politicians and the commission and the units, it's really about accepting and understanding it's a hybrid world. It's no longer analog plus. None of the tools of the 20th century analog plus world are working anymore. We had 18 acts by the last commission. This commission also, again, has 6 lawyers, 2 journalists, 1 business consultant, and 1 physicist. Imagine I do a European AI startup, and they ask me, I go to investors, and the investors ask me, who's your board? And I say, well, my board, 6 lawyers, 2 journalists, 1 business consultant, and 1 physicist. They're probably not going to fund me. Of course, I mean, I love lawyers. I've got nothing against any of the skill sets. It's all very important. I'm not saying that. All I'm saying is, at this moment in time, we need different skill sets in the commission. We need people like Simone in the commission, like Simon in the commission. So we need sort of, and so the way I hope to see it is that we finally are able to build an expert layer, and we can drop all other governance layers, and local implementation we leave to citizens. So, but the infrastructure needs to be built by the experts now, and the experts are not the people who are going to give us another 18 acts. These are the people on the ground doing the work, and they should be running that vision. So I hope that's going to happen.
We had some great comments from Guido on a lot of your statements, Rob, talking about the blackout, Netherlands, 6G. But we have a question from Jacob. What type of failure is the sector least prepared for right now?
I think the sort of, I mean, in terms of the energy sector, I cannot speak so directly on that. That's for Simon and Andres. But in terms of the sort of the I think it's the lack of trust in citizens in the ability of their leadership to deal with the digital. And every day, these citizens, 450 million in the European Union, are seeing that the leadership is failing them. And it's not good. It's not going to be good enough to say, let's replace a few things with things. No, we need a coherent vision on a hybrid territory, including energy, including connectivity, including water, including AI, and sort of all these things. So I think we're very close, like we are in the Netherlands, to this August 25, 4% of people having some confidence in their political leadership. If that goes to the European Commission level, then I think it's the end of a lot of agency.
Andres, what is your take?
Yeah, I would say it is still the integration of AI in the particular electricity sector. It will happen anyhow, because you need forecasting, you need data, you need a lot of also congestion management, you have a lot of things, but how to do it in trustworthy way, we don't know, and that could increase the system risks, because usually regulation, with all the good intentions that I mentioned, is coming late. So that's where we will have a challenge, and that could lead to unpredictable consequences, or perhaps we will manage and we will be just great. So Simon, so far he made very good job. So with all wrong data sometimes, and I imagine what a headache it is. You have a time where you could now make a reaction. So how to deal with this, but people still manage. When you meet old sister TSO operators, they usually complain that system is unmanageable because it's very much changed compared what it was. But so far we are coping reasonably well, but Iberian blackout is definitely a huge wake-up call.
Simon.
Yeah, I wanted to say first that I like the distribution of this panel, because we have very different takes on a simple question of what type of failures the sector is least prepared for right now. In my mind, I immediately thought about humans, right? That's the first thing I thought. But at the same time, even if I would say that most times that we have a failure, like a true failure, it's human cause. Somebody pushed some new code to a production server that didn't go well, right? Something like that. At the same time, there is only humans that are able to fix it afterwards, right? And fix it really fast. Like we're talking about sometimes just minutes, right? Notice something and go, oh God, no, what happened? Oh, we did this. Oh, pull it back, roll back, do it right now, right? And then they figure out the details. What server was it? Is this the correct version that we pushed? Then we check our logs and whatnot. And it's people doing that work too. So to kind of end on maybe on a positive note, right? That we create problems, but we also solve them, and human ingenuity is not to play down, I think.
Yeah, I think that's the perfect ending. We are way over time. Before we wrap things up, I would like to ask one key takeaway from each of you in one word from our discussion.
That was hard to do on the spot. This discussion, I found it useful. That's for sure.
Well, I would like to apologize to all the lawyers and journalists, because I didn't mean it like this, sort of to come out like this at all, because we need all the skill sets. And I myself come from literature, so I mean, what I want to say. So just first, I want to apologize, and then I think agency and trust. This is yeah.
Andres.
I would take both from and Simon. from one side, it's very technical issue, but at the end of the day, humans create errors, but there's also they fix and they move forward. So still humanity with all the deficiencies have managed all the technical challenges, the questions that we have not too high costs about it.
Yeah, I would say it's all about resilience from my side. Let's wrap things up. Thank you everyone who joined our Energy Hour Preventing the Blackout. Thank you so much to our speakers for such an interesting discussion. This was great. I hope to see you all at the next Friends webinar. Bye for now.
Bye-bye. Thank you.
Bye. Thank you.